One of the interesting parts about Kc is that you can manipulate it. And we learned about manipulating before in thermochemistry using Hess's law. And this is kind of similar to it, but not exactly the same. You don't add and divide. You actually, add or subtract. You will actually multiply and divide. Okay, so you change that a little bit. But anyhow, so I have a whole variety of expressions here for us to work on. So the question is, the following reactions have the equilibrium constants given below. Calculate the Kc for the equations that follow. All right, so these are the two equations we are working with. The Kc is given to us for both equations, and then we are going to be calculating for these equations right here, okay, all A, B, C, D, E. But before we go on, I just want to go ahead and write the Kc expression for both equations. Okay, so Kc and 1. 1 is for the first equation, and this would be then NO squared Br2 divided by, and the concentration of NOBr squared. Okay, that is for first equation, and Kc2 for the second equation is BrCl squared and Br2 and then Cl2, okay, as well. The reason I wrote this is because later on when you manipulate these equations, hopefully you will see how things are inversed, although I will explain how we did things anyway. Okay, so the first equation that we're working on here is 2NO plus Br2 to give 2NOBr. Okay, and so we're supposed to actually just use the Kc given to us over here to find the answer, but I'm going to show you how this works also. Okay, so let me give you the answer first. The answer is that you look at the equation that you have over here, and this is actually the opposite of equation number 1. Okay, it's just opposite. So it's opposite of equation 1. So if it is an opposite of equation 1, it means that it is inverse. And if it is inverse, then you take the inverse of Kc. All right, an inverse of Kc would be then 1 over 0.014, and that is 171. Okay, so how is this inverse? And the best way to look at that is by setting up the Kc for this equation. Okay, so now you have NOBr squared on the top, and then NO squared and Br2 at the bottom. And if you compare this equation with the Kc equation over here, you will see that they are opposite of each other, and that is why you can inverse the Kc. And I hope you can see that reflected in all the equations as we work through. Okay, so I'll do the answer first and then explain how we get that answer. Okay, so that is for equation 1. The second equation that we have here is 4NOBr plus 4NO and 2Br2. So then if we look at this equation back again, all we can see is that it is double of equation 1. And if it is double of everything, then Kc will be squared. And so if Kc is squared, then you take 0.014 and you square that, and you get 2.0 times 10 to the negative 4. Okay, and so that is going to be our answer. And if you want to set this up, again, you can just go ahead and set it up as NO4 and then Br2 raised to the power of 2, and then NOBr raised to the power of 4. And if you compare this equation to our Kc equation again, okay, over here, this one, then you will see that it is double that. All the coefficients are doubled. Okay, so if you double all the coefficients, then you have to square the Kc. All right, so that's what we did over here. All right, moving along then to the next equation. And the next equation is NOBr plus NO and half Br2. So now if we are looking at our equation, everything is half. So half of equation 1. And if everything is half of equation 1, then Kc is going to be square rooted. Okay, so square rooted or inverse half, or not inverse half, but let me just write square rooted. Okay, because that's the easiest way to say this. So take the square root of 0.014. Okay, so once you take the square root of Kc, you will get 0.12. And by the way, Kc square root is also represented by, if you raise Kc by half, right? So if that's how you want to put that in your calculator, that's how you should do it. Let's look at the equilibrium expression for this one, and it's NO, and Br2 is raised to the power of half, and then NOBr. And again, if you compare this equilibrium expression to the one that we have here, yet again, okay, then you will see everything is halved. And if everything is halved, then Kc has to be square rooted, or you have to take the square root of Kc. Okay, so that's how you would set that up. Next one. Here we have 2NOBr plus Cl2 to give 2NO and 2BrCl. Now in this case, what we've done is you have added equation 1 and 2. Okay, so 1 and 2. Both of them have been added. If you add both of them, then you have to multiply Kc1 by Kc2. Okay, that's the only way to do this. So 0.014 times 7.2, and the answer is 0.10. Okay, so that's what you get. And if you want to set this up again, it can be BrCl squared. All right, and now you will see that when you're doing this, you will have the Kc of both of them. Okay, so I will show you that in a second. And then NOBr squared, and then Cl2 at the bottom. So looking at this equation, adding equation 1 and equation 2, it means that you're adding Kc1 and Kc2. So which means that some of the things are going to get cancelled. So like Br2 is going to get cancelled, okay, over here. So then you are left with BrCl on the top, NOBr on the top, no Br2 anymore, NOBr at the bottom, and then Cl2 at the bottom, okay, because the Br2, the bromine is gone. Bromine was the same on both sides, okay, so you had to cancel that. So that's how you will set up if you had to add two equations, okay, in this case. All right, the last one, NO plus BrCl plus to give you NOBr plus half of Cl2. Now in this case, it's a little bit different, okay, and I want you to look at D, okay, for this one, and you will see that it is inverse of D and half of D. So which means we have to do two manipulations here. We have to inverse D, and then we have to half it. Half means square root. Okay, so which means that really what we're doing is first we have to inverse D, answer of D, and then we have to square root that. Okay, so which means that you will take the answer over here, so 0.10, okay, and then you will square root that. That is what's going to happen here. Your answer should come out to be 3.2, okay, for this. The other way to do this, okay, is to look at the two equations, all right, and this is the long way. This is the long way of doing it, but the long way would be that equation 1 is reversed and half. Equation 2 is also reversed and also half. Okay, and so if both of the equations are reversed and half, then, you know, that's the only way to do this, is inverse the Kc values and then take the square root of them, which is exactly what we've done over here using the answer from D. okay, because we had already done this problem in D before, so all we had to do was inverse that and square root it. Okay, hopefully it's all clear. And here is the equilibrium expression for this. Cl2 half. Try to make life easy for yourself. If you don't have to look at the original equation, then don't look at it. Maybe you have solved it in the middle somewhere, and so you can use that answer. So that's what we did for D and E, is that we used D to solve for E. Okay, so that's how you manipulate Kc. This problem pretty much has everything in it. Okay, so hopefully we don't need any other problem, but if you do, just tell me in class.